What is the status of science? Is it our best understanding of reality in all of its complexities and magnificence? Do its methods, developed over the course of generations and centuries now, give us increasingly sophisticated tools for understanding that complicated reality? What is the value of science? It generates knowledge or verifiable beliefs or reliable beliefs. Is it purely in the cognitive realm, or is it also that we can take scientific products and apply them practically in technologies and in forming habits and actions in our own lives? And perhaps also part of the value of science is just in the awe with which aesthetically it expands our range of appreciation of the world by opening up new vistas for us. What is the status of science relative to other human endeavors, religion, politics, art, philosophy, all of them significant in various ways? Can we say, though, that philosophy has made progress, right? Or perhaps that politics is in fact a progressive discipline, and the same thing, say, for religion? Or is it the case that science, compared to the other disciplines and areas of human endeavor, is in fact the one area that can make a legitimate claim to progress? I'm going to devote this podcast primarily to Thomas Kuhn, and two of the most famous philosophers of science in the 20th century, Karl Popper and Thomas Kuhn, are standouts. Karl Popper published his first major work in the 1930s, Logic of Scientific Discovery, in 1934. And Kuhn published his first work in the philosophy of science about a generation later, in the 1960s, in 1962 to be precise, The Structure of Scientific Revolutions. And that generation gap from the 1930s to the 1960s was extraordinarily important in the evolution, or perhaps devolution, of the philosophy of science. Philosophers of science can be arrayed along a spectrum, from those who are more optimistic and rational about the scientific enterprise. At the other end of the spectrum, those who are more pessimistic and non-rational in their analysis. And what seemed to happen over the course of the middle part of the 20th century was a roughly 30-year slide until the more skeptical, non-rationalist, or in some cases anti-rational understandings of the scientific enterprise came to the fore. Now, Thomas Kuhn was a professor at the Massachusetts Institute of Technology, an author most famously of The Structure of Scientific Revolutions, and it's deservedly a classic in the history and philosophy of science. However much I will disagree with it, it is a classic. And it's still relevant now, well over half a century later, to our philosophical and cultural debates over science. For Kuhn challenges, and he challenges in a deep and important way, the claims that science is or can be an objective process based upon observational facts, and that science makes progress towards something we might call truth. Now, a slightly broader context, Kuhn and philosophers of science are, of course, very interested in the methodology of science and what distinguishes science from non-scientific areas of investigation. And so we have this concept, or set of concepts, integrated into what we call the scientific method, or scientific methods, right, that we might still give the collective label. Of course, by the time we grow up and start thinking systematically about the world and perhaps become professional scientists or followers of science, we nonetheless have a lot of background knowledge and a lot of background beliefs. But at some point, we start to become self-conscious and systematic in our investigation. And there's something about that self-conscious and systematicity that leads us from being ordinary people who may or be rational in our lives to those who are professionally rational and directing their efforts toward professionally trying to acquire more knowledge about the way the world works, and those people we call scientist. So based on, though, our background knowledge, we then start to observe carefully particular things in the world and how they act and their properties. And so we start to observe carefully. We then, of course, form concepts where we abstract from our perceptual observations. We put things in more general categories. We measure them in varying degrees of precision, and we come up with schemes of classification. And we, in abstract form, we define these concepts and the perceptual objects that they subsume. We take particular concepts and start putting them together in more sophisticated cognitive structures that we call sentences, or more abstractly propositions. And we develop methods of putting concepts together by means of grammar to make sure our sentences are picking out phenomena in the world in a way that allows us to retain them and communicate them to others. And we take propositions, individual sentences about the way things work, and put them together into yet more complicated structures that we might call theories, or if we're making up stories, we might call them narratives or fictions, and so on. But there is a matter of logic. We want the various sentences in our stories or in our theories to fit together. So we use tools of logic and mathematics to make sure that the various propositions and so forth are consistently connected to each other. We're developing, to use this more scientific language, predictions, explanatory hypotheses, and so on. So to take just one simple example, we grow up and we are aware of the environment around us, but at a certain point we have enough concepts in our vocabulary. We're aware of water, and we're aware of rain, and we can see clouds, and we can see rivulets and perhaps streams of water that have collected. And we might see water boiling on a stove or from a kettle, or if we're outside and observing carefully, see steam rising from a hot pavement on a summer's day. And so we have all of these observations and all of these concepts that we have formed, and at some point we start putting it together in a theory about, a theory that we might call the water cycle, that says water can, when heat is applied to it, become vapor and rise up into the sky, where it gets cooler and condenses into clouds. And then the clouds then will precipitate, and rain or snow, depending on how cold it is, will fall to the ground, and it will then collect in rivulets and streams and various other places. The sun will come out and heat that water, and it will steam, and then the process will continue. Now there, what I have is a huge number of observations, a large number of concepts, and it's all integrated into perhaps a dozen or so sentences or propositions, all of which are linked together in an explanatory way that enables me then to make certain predictions, and that whole network we will call a theory. And then we might do experiments to fine-tune our observations in different circumstances and to test the explanatory hypotheses. And when we're doing experiments, of course, we are acting in the world. We're applying the theory. We're trying to generate new observational data. Then we're going to use that new observational data mathematically and logically to evaluate the theory. So all of that is then just a thumbnail sketch of scientific method. And philosophers of science, particularly those interested in the epistemological aspects of science, will then look more carefully at, well, what's the status of these background beliefs that we bring to bear? What's the nature of observation and experimental design and concept formation and classification and the logic, or rather the grammar of proposition formation? And what's the status of the logic and mathematical propositions and principles that we use to integrate and so forth? So we subject all of them to sophisticated analysis. Now, by the time we get to the the first third or the second quarter of the 20th century, after World War I, things have calmed down. Philosophy of science, of course, is a going concern, and there's all kinds of activities. Science is doing very sophisticated things in biology, in chemistry, in physics. It's very exciting times. There are debates over whether psychology is now sophisticated enough to be considered a science as well. And the philosophers who are interested in science are extraordinarily busy as well. Logical positivism is well known as a discipline. Much of the activity centered in Vienna. Ludwig Wittgenstein with uneasy relations to the logical positivists. The same can be said about Karl Popper and so forth. Now, I don't want to overstate how science-friendly the philosophy was at the time, that broadly speaking, philosophers in the analytic tradition, as we think of it, were friendly towards science, and were trying to figure out what makes its claims to knowledge, truth, and progress legitimate. But at the same time, there was an extraordinarily significant amount of skeptical analyses being directed towards science, and many of the leading proponents of science were already starting to undercut many of the components of scientific method. And so I want to say Karl Popper was one of the more pro-reason, pro-science figures at this point, but at the same time he was mounting vigorous debates against those who are starting to undercut the claims of science. So, for example, in the 1930s, we find many philosophers of science arguing that perception can't be something that we take to be basic or to give an independent check on hypothesis formation and theories, because perception itself is laden by theoretical presuppositions, so that to some extent we see what our theories are allowing us to see, and if we're only seeing what our theories allow us to see, then it's not going to be the case that observation can then be an independent objective check on that theory. Or there were many theories of perception that were prevalent that saw the objects of perception as subjective representational creations inside our heads, and so they're not actually putting us in direct contact with reality, and so we have to make inferences or guesses about what the nature of reality is beyond the perceptual veil, so to speak, in which case we have an obstacle toward perception being able to put us in contact with a reality, and so being able to serve as a basis for scientific theorizing. There are widespread nominalistic theories about abstraction and concept formation, arguing that we can't really say that concepts are picking out objective essences or actual universal facts. Instead, that they are subjective groupings that we conventionally, individually, or depending on our group backgrounds, are picking out, and that there's no necessity to the way we form our concepts. Language itself is seen as by many as a cultural project, and is therefore subject to all sorts of historical contingencies and oddities, and perhaps ultimately arbitrary. So here's Moritz Schlick, for example, a leading positivist, from an article called Meaning and Verification, arguing that, quote, "the rules of language are, in principle, arbitrary," unquote. So if the language itself is arbitrary, and scientists are just taking an arbitrary tool and communicating with each other and thinking by themselves in terms of language, well, ultimately science then perhaps is arbitrary. Well, as for logic and mathematics and their alleged claims to universality, necessity, and objectivity, already in the 1930s there were many critics of those claims. A.J. Ayer, for example, from his widely influential Language, Truth, and Logic book, made the following claim, quote, "the principles of logic and mathematics are true universally simply because we never allow them to be anything else," unquote. Notice the claim here that it's not that they're true universally because of any facts or universal facts or about the structure of reality that they are picking out, but rather we have made a decision that we're just going to legislate that they are universally true. But of course, what's legislated can be unlegislated, and so there's an undercutting of the status of logic and mathematics. Do scientific theories give us truth, particularly when they're talking about all the these highly abstract and in many cases speculative objects of knowledge, quarks and subatomic particles, and this is a little bit anachronistic, but quasars and black holes in the next generation of science, things that we can't immediately see. So we have all these theoretical constructs and so on. Well, by the time we get to the 1950s, one leading thinker, a more pragmatic thinker, W.V.O. Quine, argues that in principle there's no difference in status, right, between the Homeric gods, that is to say, the gods that the Greek poet Homer, 2,800 years ago was positing in his fictional epic poems, and the kinds of things that contemporary scientists say that they believe in. So, quote, "Physical objects are conceptually imported into the situation as convenient intermediaries, not by definitions in terms of experience, right, but simply as irreducible posits, comparable epistemologically to the gods of Homer." Carrying on the quotation, right, "In point of epistemological footing, the physical objects and the gods differ only in degree and not in kind. Both sorts of entities enter into our conception only as cultural posits." So, a cultural posit. So you're working with a group of scientists and you're going to posit that there are these kinds of physical entities out there. We'll give them various sorts of names. But just Homer was a poet working in a different cultural context, and he posited Zeus and Athena and Ares and various other ones and so on. So they're all just on the same status and so forth. Now, all of that is prominent in philosophy of science by the 1950s. Philosophy of science is in a very skeptical phase. Kuhn is well grounded in physics and in the history of science and is doing work in the history of science in the 1950s. But in the early 1960s, he turns to writing philosophy and the sociology of science, and in 1962 publishes his landmark, The Structure of Scientific Revolutions. What Kuhn does in The Structure of Scientific Revolutions is integrate all of the skeptical undercutting themes in analyzing science philosophically and adds a few more. Now, first, a terminological point. Probably the most famous word to come out of Kuhn's Structure of Scientific Revolutions is the word paradigm. And essentially what Kuhn wants to do is use paradigm to mean a scientific theory, but to come up with a new word that doesn't have the baggage of the word theory or the word like worldview. And so what we have is an interconnected set of propositions that people will use to explain and predict various phenomena. And then a paradigm then is an organizing, right, belief system that, if we're not Kuhnians, we would just call a scientific theory, or perhaps in more social sciencey language, we would call it a world view. Now, the Structure of Scientific Revolutions, then, the significance of the title is that Kuhn wants to say that science proceeds by alternating periods of normal science and revolutionary science. And he wants to provide an account of the structure of this process. In times of normal science, there's a paradigm that's pretty much widely accepted by the members of a scientific community, and within that scientific community, it's largely uncontested. But then what happens in times of revolutionary science is a new paradigm is proposed. There's a kind of battle between the new paradigm and the old paradigm. The new paradigm gains converts. The old paradigm slowly goes away. And then we're into a new era of normal science where the formerly revolutionary paradigm is normalized. Now, paradigms come from individuals, individual scientists, of course, but by the time they become scientists, those individual scientists have a large number of background beliefs, And that's comes from a mix of conditioning. They all grew up in families, communities, societies more broadly speaking, and they've been largely conditioned in a certain worldview, a non-scientific worldview, one though that might include some scientific elements, and that forms their background cognitive context. But of course, people also are individuals. Individuals vary, and so individual scientists have their own uniqueness. But the point is going to be, and Kuhn stresses, is that social circumstances and individuals are highly variable. And so what that then means is that when we have someone who's generating a new paradigm is going to be what he calls incommensurable with an earlier or pre-existing paradigm. A person who comes up with a revolutionary paradigm comes up with the idea of new posits, of new kinds of entities, sometimes comes up with the idea of new methodologies and so forth. And the way Kuhn puts it is to say the new paradigm gives the new way of thinking a different way of looking at the world in a fairly radical sense. And the fairly radical sense is what this term incommensurability is meant to capture. The objects and the methodology of the older paradigm don't fit with and can't be translated into the objects and the methodologies of the new paradigm. So this is a quotation from the second edition of Structure of Scientific Revolutions, quote, "They are, quote, incommensurable ways of seeing the world and practicing science in it," unquote. Now, science students, though, before they become fully credentialed members of the scientific community, they will learn the normal science paradigms that are prevalent at the time that they're going through school. And Kuhn stresses the somewhat conditioning aspect of this process, that rather than thinking of science students as independent, courageous, free-thinking individuals and so on, Kuhn goes out of his way to point out that science students, they don't have a lot of time, they don't have a lot of expertise. In many cases, they have authoritarian professors, they have textbooks that they are expected to memorize, and they have answers in the back of the book. And so what scientists do is they learn the normal science paradigm essentially by parroting their professors and the textbooks. They do not engage in anything that we can call an independent, objective, or first-hand assessment of reality. Quote, "Science students accept theories on the authority of teacher and text, not because of evidence. What alternative have they, or what competence?" Unquote. The students need to absorb, memorize, and regurgitate in order to pass the test, to get the credential, get the degree, the PhD degree presumably, to get the job. And to get the job, they need to have the approval of the scientists who are already working in their field. But those scientists who are already working in the field are committed to a paradigm. And if you don't accept that paradigm, you're just not going to be accepted. So by the time then they do get their degrees, they do get their jobs, and they become practicing scientists, they are working strictly within a paradigm. And Kuhn goes out of his way to say most scientists, sure, they're intelligent, but they're not first-rate geniuses, and they are going to be the kinds of individuals who go to the office, go to the lab every day, and it's work a day on the job. They are working strictly within a paradigm. They're typically working on and only on issues and seeing the world the way the paradigm specifies. The way Kuhn puts it is to say that most certain ordinary scientists are doing what he calls, quote, mop-up work. They're not original thinkers. Another quote, "No part of the aim of normal science is to call forth new sorts of phenomena. Indeed, those that will not fit into the box are often not seen at all. Nor do scientists normally try to invent new theories, and they're often intolerant of those invented by others." Unquote. Another quote about the research inside a normal science era. Quote, "We shall want finally to describe that research as a strenuous and devoted attempt to force nature into the conceptual boxes supplied by professional education." Unquote. quote. So you've got your theory. The theory lets you see certain things, and whatever data comes in, you're trying to squeeze it into the pre-existing categories that your normal science paradigm or then its conceptual boxes want you to fit it into. One more quote on this point. Quote, normal science, for example, often suppresses fundamental novelties because they are necessarily subversive of its basic commitments. Normal scientists are not open-minded. They're not able independently or interested in seeing the world as it really is. They're interested in fitting things into their pre-existing theories, and the pre-existing theories was largely conditioned into them during their student days. But even so, in the course of normal science, problems do arise for the paradigm. And the problems that are called anomalies by Kuhn. They arise, and at a certain point, no matter how pig-headed or strenuously going through mental gymnastics scientists are to try to get them to fit into the pre-existing paradigm, someone eventually will come along and propose some substantially different explanatory principles and methods. Someone will propose, that is to say, a competing paradigm. But that competing paradigm, if it's going to work with all of the anomalies, it's got to be quite different. It's got to be incommensurable with the pre-existing normal paradigm. So they define terms differently, they propose different explanatory principles and methods. So they, as Kuhn puts it, have created a different subjective reality. And here's a direct quote from Kuhn on this point. The proponents of competing paradigms practice their trades in different worlds. And the different worlds part of the quotation from Kuhn is lent metaphysically there. It's not that they're focusing on different aspect of the same world, right? Or, that one person is practicing in Los Angeles and another person is practicing in Göttingen. It means that the world that your theory is subjectively creating for you is different. That's the reality in which you inhabit. Now, what this then implies, though, is that since the scientists are operating in different worlds, and they have different beliefs about the objects that populate that world, and they have different beliefs about the proper method, it follows then, quote, the competition between paradigms is not the sort of battle that can be resolved by proofs. Unquote. That's to say, this is not a matter of best assessing logically the amount of data and which one better integrates the data completely without leftovers and so forth. It is not a matter of logic and proof. And then he draws an analogy, quote, like the choice between competing political institutions, right? Unquote. Notice the politics. It's going to be essentially a political battle, and we're going to sort out competing political paradigms, or rather competing scientific paradigms, the same way we sort out competing political paradigms. Now, picking up the quote again, like the choice between competing paradigms, that between competing paradigms proves to be a choice between incompatible modes of community life. And so it comes down to a power struggle. You've got the old and traditional paradigms versus the new and more radical paradigms. And either power is going to prevail, or as Kuhn starts to successively introduce more religious-sounding language about the change of belief, some of the people who are operating, some of the scientists rather, who are operating within one paradigm will make a kind of leap of faith into the new paradigm. And so changes of scientific belief, as Kuhn increasingly starts to characterize it, become like those in religion. They are matters of quote unquote faith, or the shift from believing in one paradigm to another is quote a conversion experience unquote. Now, Kuhn draws then a more radical implication from everything so far. We're switching from paradigm to paradigm, and there's lots of new paradigms that have developed over the course of the history of science. But Kuhn argues that everything that we have said so far means that we must reject the idea that science progresses. Right? Progress is a word that he starts to put in quotation marks. It becomes a subjective myth. All you have is people operating within different paradigms, but those paradigms tell you what you see in the world. They create its objects, they create the methodologies, they tell internally consistent stories, and in many cases, right, people are locked into that both cognitively and in terms of their social standings in their different scientific communities. So there's no way that you can evaluate objectively different paradigms. Just each person is locked within their own paradigm, and so we don't have any standpoint from which to say that one is better than the other, or that across time one is an improvement over the other. Progress is thus undercut. And this is a quotation directly from Kuhn on the point of progress. Quote, "The answer to the problem of progress lies simply in the eye of the beholder," unquote. So say that it's in the eye of the beholder, of course, that's a cliche for saying that it is subjective. Further, the idea that truth is what science is about. Truth is a word that we have to start putting in scare quotes and distancing ourselves from. Another quotation here from Kuhn, quote, "We may, to be more precise, have to relinquish the notion, explicit or implicit, that changes of paradigm carry scientists and those who learn from them closer and closer to the truth," unquote. So truth is another notion that we need to have to give up, have to relinquish. So objectivity, truth, progress, all of these are undercut. Instead, what we have is subjective hypotheses that are conditioned into us, that we may undergo conversion experiences and adopt a new paradigm on faith, but we can't say that the traditional Enlightenment era optimistic story about science is at all correct. Finally, what we then should say is, drawing on the analogy that Kuhn had started to draw earlier, that science is not only pretty much the same thing as religion, but science is pretty much the same thing as politics. And if we are cynical about the way politics goes, we're going to end up being pretty cynical about the way science actually goes in process. Science's truths are merely authoritarian power politics applied to the scientific community. The subsectors within the scientific community, those institutions that have the most power, they dominate. They legislate what counts as truth, and they enforce it by all of the standard means of social standing and politics at their disposal. So the way Kuhn puts it in this quotation here is to say, quote, "Inevitably, those remarks will suggest that the member of a mature scientific community is, like the typical character in Orwell's 1984, the victim of a history rewritten by the powers that be. Furthermore, that suggestion is not altogether inappropriate," unquote. So that's academic speak for saying, really, Orwell's 1984 dystopian authoritarian politics portrayal, that really is the best understanding we can also apply to how the scientific community operates as well. Now, all of this then is to say, and to go a long way toward explaining why Thomas Kuhn still matters these decades later, because his work is a classic, partly because it does mount a powerful philosophical and social and psychological attack on Enlightenment understandings of science, but he has provided ammunition for all sorts of movements and sub-movements that see science as an obstacle to their agendas, sometimes intellectual, sometimes political. So Thomas Kuhn is a darling and widely used by those who are attracted to analyses of power, and typically from a more postmodern leftist perspective, because what Kuhn enables postmodern leftists to say is to say, quotes, something like, see, science is just a subjective system, right? It's just entrenched by power. It's just one more narrative that certain individuals happen to be able to wield over those who have different belief systems. It's the powers that be. Most of them happen to be European in origin, or most of them happen to be male, or most of them happen to be white, and they just have their paradigms, and they've been socially and politically successful at ramming it down the throats of the rest of it. But really, as Thomas Kuhn shows, their paradigms are no better than any other group's belief systems or paradigms. And what this then implies is that we shouldn't give science any particular standing or esteem in our considerations, and we should make equal room in the curriculum for other ways of knowing. Now, we can also say, though, you can find many citations in the literature, that Thomas Kuhn is someone that those on the religious right, using that as a shorthand label, and those who are interested in faith-based, explicitly religious systems will find very amenable. So they can say, see, science is no better than religion in terms of faith and conversion and so forth. Yeah, we're all about faith and trying to convert you to our subjective faith. But as Thomas Kuhn has proved, right, stick your reference in there, science is just as much faith-based conversion matter and so forth. And so, for example, we can say, evolution is a paradigm, it's a theory, but it's just as much of a paradigm and theory as evolution is. And so since they are equally paradigms and subjective systems, we should have equal time in the classroom for creationism, say, and evolutionary theory. And the point then is that both the postmodernists and the religious, normally they are seen as enemies of each other, and certain strong segments of the left and certain strong segments of the right, again, who are often seen as enemies of each other, they will find common ground, common ammunition, common solace and help in Thomas Kuhn. And that in large part explains why he has become a household name, not only in academic philosophy of science, but also in many subfields in the humanities and the social studies. So in conclusion, I do want to sound once again my theme that I've been sounding regularly in this Open College series. That on most major issues, get away from binary thinking and see that at a minimum, there's always going to be an important three-way debate. In our contemporary culture, we find many advocates of old-fashioned religion, and they will say that explicitly they are advocating faith-based subjective belief systems, and they can't necessarily prove their systems, and they will recognize that science is a threat to that approach. But then at another part of the spectrum, we'll find those who are advocating group conditioning as the basis, and various kinds of cultural conditioning as the basis for their subjectivism. In many cases, those who are advocating faith-based religion will be on the political right, and those who are advocating group-based multicultural subjectivism will be on the political left. But you'll notice that both of them are opposed to any sort of reason-based objectivism and the scientific enterprise that aspires to be and can be and often is, in fact, an alternative to both of them.